it's James from Finney Electrical, and today's video we're doing a bit of testing with this donkey. And we've got a little surprise for you at the end of the video, so keep watching. There we go then, so Aiden's got the lights off at the moment, doing some testing. Don't know how well you can see. But basically, we've started testing the lights. We're getting good readings in this little office then. So there's like a room here, and there's a front of the shop. We're getting some really good readings on the lights. So I think there's just a few of these. All terminations of sound, there's no exposed singles knocking about. But then we got to the back area and we did some dead testing on this light. No earth. Switch, no earth. I said, right, let's come into this then. So basically there's an earth in this set, but there's no earth in the cables coming out of this one and this one. So what we're doing now is just linking these out, just so this passes this bit of the test. So we're testing, you're supposed to kind of just test it and then come up with a big list of bits that need doing. But since we've got the switch off, we might as well just kind of fix it for them. So some testers out there, they'll basically just put, yeah, needs further investigation, and then come back and charge to do that. But yeah, because we like to be nice, we don't do that. So as far as testing then, we've got the cert set up. So we've got the little certificate here. We use a software called NAPIT Fast Test. That's by NAPIT. So it's nice and easy on the laptop. You can fill out your circuits really easy instead of in pen. My handwriting is terrible, so it works for me. Fuse boards over there, we'll show you that shortly. Right, here's the board we're testing then. So I think it's was it 13 wires? Let's have a look. There's 13 breakers there. So yeah, it's a little bit squishy, but we've got a little bit of room to play with. So what we're going to do is go through each circuit. Now there's different types of circuits. Kind of blinding myself here. We've just got a radial circuit where it'll wire from the fuse board to every point and then just stop. And then there's a thing called a ring. Well, it's just wired as a ring, and that'll be for the sockets. So if you look here, in here there's it's a 2.5 cable. There's two cables in there, two conductors. And that will be for the socket. So it basically wires from the fuse board to every socket and back, and it just allows you to have the circuit at a 32 amp. So it gives you a little bit more kind of tolerance, because if not you'd have to put it on a 20 amp, so obviously you lose 12 amp there. So there we go. So then we'll show you those tests. So when you're testing, there's something called a dead test. Where you got dead tests and live tests. Your dead tests are something called continuity. So what you do, you take the line out, you take the earth out, you connect them together, and then you go around every point and check that you get a decent earth reading all the way around. And if you don't get a reading, then it means it's not earth. So that's what happened just then. So we connected those up. So it's kind of put it back a little bit now. But then we went round, and then there was no earth on the back light and no earth at the grid. So we had to investigate into that and try and fix it. And then the other test we've got then, so we've done that. There's one called insulation resistance. So you kind of disconnect all your loads, test between line to earth, line to neutral, and neutral to earth, and you should be getting like a really good reading, greater than 500 mega ohms, or million ohms, which is obviously a very large number. And what that's doing is just sending a voltage down the conductor, and it can actually tell you how broken down the insulation is, and that will tell you if you need a rewire or not. So if it's under, like, if you get like under 1 mega ohm, then yeah, you need to be looking at investigating why it's that way. And if it's just a cabling that's broken down, then yeah, you'll need rewiring. So other dead tests, we've got so when we talked about the ring circuit, you basically have to do end to end. So if you imagine you've got live, earth and neutral on one cable going all the way around and back. So you want to make sure that's the case. So you take the line, you take the two cables out, and you're testing this line to that line of each cable, and it should go all the way around and back, and you record that reading. So you have to do that for line, neutral and earth. Then once you know it goes all the way around, then you do a crossover test. You basically take the line in and connect it to the line out, the earth out, and then the earth into the line out. So it kind of crosses it over, and then you go around every point and you plug in, and you should be getting similar readings within rule of thumbs like 0.05. If you're getting higher than that, like 0.1 difference or higher, then it could be a spur or like loose connection, that kind of thing. So that's that test. And then finally onto the line test then. So the live tests, we've got the RCD test. So if you look here, we've got a little 80 amp, 30 milliamp RCD. So we'll have to do a test on that. And again, that should trip. So for one time, so 30 milliamp test, it'll trip within 200 milliseconds. If that passes, then the RCD passes. And if we do it 5 times, it needs to trip within 40 milliseconds. Because basically, that's the kind of touch I can't even speak today. That's the touch volt contact. So not enough current. Well, not enough current will basically flow within that time period, within 0.4 of a second. So basically saves your life. Stops you getting electrocuted. In easy words. Well, so same again for this one. So this is a 63 amp RCD. So just make sure they're working. And then finally we've got the ZE test. So it's the line cable all the way back to the transformer. Wherever it comes in. So obviously it gets generated, it gets stepped up into the power lines, and then gets stepped down into your power plant room, and then you end up, well, in this case it's commercial, so it comes in three phase down there, but then only one of the phases is used for this unit. But yeah, it's testing that line all the way back to that plant room, and it's testing the resistance between line and earth. So that's what that test is, and I think that's all the live tests. I might miss something, but we'll go through it now. So let's crack on with this testing. We have light. Right then, so let's crack on with the test. So we'll show you a radial test. So we've got a fire alarm cable here. So this is for the fire alarm. So what we'll do is disconnect it. So we're going to disconnect line, earth and neutral, and then what we'll do is just get ready to connect it up, and we'll talk you through it. That's out now, so we've got the live earth and neutral out. So then, let's do this. So what we're going to do first, we're going to do, it's called a continuity test. What we're going to do is connect the earth to the line, and we're going to use these little crocodile clips. These are quite handy, these. So you could use a connector block, but it's a lot easier just to clamp on, give it a good grip, and that's going to connect line to earth. Then what we're going to do is do an R1, R2. So R1 is your line, R2 is your earth, and we're going to go to the end of line. Well, there's only one point for this because it's basically like a red switch fuse spur for the fire alarm. So we'll open that up and we'll get a test between line and earth there, and it'll tell you that there's an earth, makes it all the way to the end, and it'll get that R1, R2 reading. Alright then, so let's open this up. So you can see your cables come in, all grommeted and that, so that's nice. So what we're going to do now is get a line to earth test. You can still hear me, little lorry going outside. So we're going to put this little bad boy on continuity. We'll attach this to the earth. I'm going to try and do this one-handed. So that's on the earth, and then what we're going to do is pop this off here and then just test to the line coming in. So, oh, wrong one. This one. There we go, 0.31. Right then, so 0.32, 0.31. Well, it made it change anyway at that last second. So we'll write that in the certificate under that circuit. For the fire alarm, it'll be number of points will be 1, and 0.31 we'll write down for the R1, R2. So now we're going to do the insulation resistance test. We'll just pull these off and get a couple of crocodile clips on, and what we're going to do is test, like we said earlier, line to earth. I like to go other way around. I'm pretty sure this tester will zap out of the red lead and then just test using the earth. So let's zap down the line to earth. So then I'll put this on insulation resistance. What I do is bang it on 100 volts first, just to make sure nothing's gonna go skew with. Then bang it up to 500, which is double the operating current of 230. So we'll do that. Same again, line to neutral. So again we'll go 100 volts, see if it's up cracking. Oh, greater than 100. Bring it up to 500. Greater than 500, brilliant. And then we'll do neutral to earth. So again, I'm a bit funny. I like to send down the voltage down the line conductor for some reason. If that's even how it works, I don't even know. Right then, 100 volt, and then back to 500. Nice one. So that's tested perfect. So that's a perfect circuit. So we're under insulation resistance. Between those conductors, we'll put greater than 500. The test voltage will be 500 volts, and then that's the dead testing done for this circuit. So that's all put back together now. So the next little thing we'll do is the ring test then. So I think we'll show you a radial, a ring, a couple of the live tests, and then that'll be it. So let's get this socket tested. So there's two cables in here. It's on a 32 amp, so we're going to assume it's a ring. Never assume, but what we'll do is pull it out, and what we're going to do is do end-to-end test. So we'll pull it out first. Right then, so we've found those then. So we've got the line cables here, earth's here, neutral's there for that circuit. I'm going to put it on continuity test. We've got little crocodile clips. So let's see if we can position this. So then what we're going to do is clamp on for line over here. So you can see that. So end to end. This is one cable all the way around the back. And we've got greater than 2000. So that's no good, is it? So there's a break in that cable, or it's just not a ring. So let's try earth, see what we've got here. Getting 2000, and then next one is this neutral then. See what we got here. Right, getting the 2000. So apparently, hang on, make sure that's yeah. So basically, they've got 32 amp, and it's not a ring. So there's either a break in that circuit. So we'll see what's not working. So it's either investigating into that, trying to find the break, or it might be that it's just two radials. So it comes from here, they go in the same breaker, and it goes off to a few sockets and stops, and then a few sockets and stops. So that's not right good, is it? So we'll need to investigate into that why. But usually you do your end-to-end tests, you get that reading, you'd write it down, and then what you do is then do a crossover. So like we said, we would have taken that line there connected to the incoming earth, so the incoming line to the outgoing earth, and the outgoing line to the incoming earth, if that makes sense. You basically just connect one of the cable to the other and then go around and test, but we can't do that now. So but we'll have to put it down the port to investigate into that. What we can do is make sure that we've got a good earth reading at all those points for the sockets. Meanwhile, so what I have to do is obviously say it's failed, it needs investigating, but meanwhile we want to make sure that there's an earth at these sockets, because we don't want people using them without an earth and then plug in something that needs an earth, like an appliance that needs an earth, and there could be a fault on it, and then, well, they could plug in, there could be no earth there, and then if there's a fault on it, it'll just stay alive, and they'll be the return path getting electrocuted. So that's not right good, is it? So yeah, then although we can still get this connected up. So what I'm going to do now really is connect lines to earth, and then see, well, line to earth, and then see what results we're getting then, which is a bit annoying. Oh well, I thought I'd show you a ring circuit, but I can't, unlucky. Right, let's crack on with this and see what results we get. Right, we'll get the plug-in tester in then. So then, let's go around then. So we're going to plug in here then. So straight away I'm seeing cracked sockets, that'll need replacing. So put that down so it's still live. That must be from a different circuit, that one. I'll unplug that. So I'll go down here. What we got? Oh, okay, next. All going wrong. Can't do this two-handed, we're filming. It's plugged in. It's still live, so that's no good. So it's not on that circuit. So basically we're going to go around all the sockets like that. Obviously if it shows it's dead, basically a little thunderbolt pops up on mine. Still alive, so that little thunderbolt pops up. So it's obviously not that circuit, so we've just got to keep going around until we can see all the sockets are accounted for, and we see some dead ones that we can get some readings at. So I'll do that. If not, this video will be well long. We've got a reading, so 0.19 to that socket there, and again that's live, that's the socket behind me live. So when you're testing, you always do both sides, because I've had it where one's like 0.19 and one's like 200 ohms or something stupid, so you can get faulty sides. So always test both sides. So you record the highest, 0.19 with the highest with circuit so far. We're going to carry on going round. Now great stage, we've got a nice little donkey here whilst we test, so we'll try and get in this socket there behind his butt. It we're live, that. What's this? Is it bucking that? Oh, it just makes a noise. That's no fun. I thought it'd start moving. Right then, so we're moving to live test now. So we've got a ZE test. Did you do that, Hayden, already? So Hayden done it already. So basically what you do a high current. So you bang it on a high current. You do line and you disconnect all parallel paths. So basically you turn the board off, take the earth out, connect to that, make sure it's not connected to any bonding down there, and you get in kind of like the worst case. So that's and then you get a resistance reading back to the fuse board and back. So that's that. And then to get the PFC, you connect your parallel paths back in and then get the same test, and then that's going to get the kind of best case resistance and the highest what do you call it, PFC reading. Sorry, my head's gone today. Been working silly hours down south. We've been doing like 14-hour days, so my head's a bit goo today. So then that's that. That's those live tests. We hasn't done the RCD test, so I'll show you how to do that next. RCD test then. So there's two RCDs. So what I'm going to do, bang it on here, put it in RCD time. It's a type, I can't see. It's a type A. No, it's not. It's just an AC RCD. Oh, it's hiding there. You see that little squiggly line there? That's type A. If it was a squiggly line with like boobs, that'd be a type B. So we need to take it off that. See that little symbol there? There we go then, that's AC now. And what we're going to do is clamp. So basically this RCD's got a neutral bar and this RCD's got a neutral bar. So we'll test this right one first. So bang that on there. Oh, it'll line it up. That's the neutral earth. And where have my line ones gone? Is it falling down here? There we go. Right. And we'll just bang this on. So it's going to trip 4 times. It's going to test. It's going to test at basically half 30 milliamps. It's going to test at 15 milliamps. It shouldn't trip. It's just done that. It's going to test at 30 milliamps and trip. And then we'll reset that one. It should trip again. Twice more. It's going to test at 5 times 30. Whatever that is. And then last time. Oh no, I think that was 4. Can't count today. Right then. So there's 5 times readings and it needs to be less than 40 milliseconds. So that's time. And then your 1 time seems to be less than 200. So that's really low that. So those results for the second RCD then. So here again here is 8.7 and 32.2. So we'll do the next RCD. So we'll do the next one now then. So we'll put it onto the next one there. So 8.7 and 32.2, yeah. So Hayden's wanting those readings. So do the next one. So we'll bang it on here. Test. So again, it's going to do half times. I'll let you watch this then this time. There we go. Trip. Oh, I can't see a thing. Oh dear. I've done it with like some weird claw technique. Ah, there we go. Ah. Yeah, there we go. That's it. So with that one we got 10.2 for 5 times and we got 36.0 for 1 times. There we go. So that's the RCD test. Now you might be thinking, what's an RCD? So basically the RCD, it's got little I think it's called a solenoid. I'm going to show you. So it's basically, you got line runs through here, you got neutral runs through here, and it's balanced. So whatever line goes through into your circuit, basically it goes down your cable into your circuit, back down your neutral, up into the bottom of here and out. Now if there's any imbalance, an imbalance of 30 milliamps, that's that, well it's down there, it's just 30 milliamps, you can't see it really that well. If it goes over 30 milliamps, it'll trip, but the normal trip is about 27 milliamp. So yeah, it will trip if there's an imbalance. Now the imbalance could be a fault on appliance or whatever. It could be you touching it. So if you accidentally touch something that came live or like a live cable, it's going to trip within 0.4 of a second and save your life. So they're quite important. That's what an RCD does. Hey, you're in luck. I thought I'd treat you. So of course the ring wasn't a ring. We've put down the report, that's it. Something needs sorting or investigating. We've got one last circuit, so we'll show you. Hopefully this is a ring in here. So I'll turn this little bad boy off. It's the last circuit of the day. So we've tested all these and there's a few faults that have popped up. So a bit annoying. So I can see a bit of wiggle there. It's those two there. Don't want to. You never want to undo these all the way and then the screw pops out. It's a nightmare to get back in sometimes. Right then, that's those two. And then I can see that these earths move then and I wiggle them. So we're going to go with them. Sometimes it's really hard to see what's attached to what. If I pull those now, then neutral's moving. So I'm happy. Let's pull one of them. So that is this core, because I saw that move. And so look. That is this core. So I do is kind of position one up, one down, and then you know all the ones facing up on one circuit, one cable, and all the ones going down on the other. So a nice little tip for you there. So then end to end then. So continuity test. So you know it's better than me now. I mean you've had the. I've told you this before and it wasn't a ring. So end to end for circuit 14. This is for Hayden to here. 0.51. and then we'll go. So that's I can't even speak today. That's little R1. So 0.51 again for Rn, and then I'm gonna bang it on here and try and get that little tip bit up there. So we'll look. Oh, missed him. Look at that. It's not very smooth, this video. We're trying to film. And there we go. And then we've got our little R2 is 0.97. There we go. And now what we're going to do is do the crossover test. I should be really stopping this. Just you'd have to see all this setup. Well, this is what I've been doing. So we're on the one side's line to the other side's earth. So I'm going to go up and down. There we go. And then we'll go up. I don't know where my short leads are gone, but I'll give them to Ed and for his little testing box. Right, get in there. Don't drop, don't drop, don't drop. I don't want to go back of this safe and try and pick them back up. So when you're putting these on, you want to be careful where other end's going, because obviously if you connect it to earth and then the other that's flapping and touches on this buzz bar, it's going to blow, so you don't want that to happen. So now that's connected up, we're now going to go around like we did before with the socket tester and see what circuits are doing what. There we go. There we go. If you remember from before then, there was this socket down here that was cracked. Let's see if it's still live. It's not. Hey, so 20.5, flipping it, that's massive. Right, we can't have that. On the other side, 20.5, my goodness. So that's very high, that one. So that's not good. Right then, let's test some other ones. Hopefully they're not all super high. But yeah, that'll need some investigation, won't it? You should be getting 20 ohms. You should be getting like 0.56 or something. There we go, 0.37. And again, we test both sides, don't we? So I'll bang this down here. Oh. 0.39. So again, 0.39 is the highest for these, and that's probably the anomaly. So there'll be something wrong at the back of that. So I'll still take kind of like the highest of the normal ones. And then if we investigate that, see what's going on, there's probably a loose connection back. As soon as we fix that, test it, it'll pull a lamp probably below this. But anyway, we need to take the highest reading. Printer. Let's have a look. What have we got here? 0.41. 0.40. Right, let's carry on going around. You don't need to see this. There we go, so last test at day. So on that circuit then, actually 0.41, but then we had this stupid one that was just stupidly high, so we're going to have to put that down to investigate into that one. And then obviously when we investigate, it's probably a loose connection behind. We'll swap the socket over anyway because it's cracked. And then if we get a higher reading than 0.41, we'll write that down. If it's lower, then we'll just stick with 0.41. Right then, so insulation resistance, last test of the day. Obviously when we're testing, we're doing a visual test. That was the first thing we did. We walked in, had a look around everywhere, we're looking for cracked switches, cracked sockets, other stuff with visual. We'll be looking for stuff not being correctly supported throughout the run. We're looking for holes in fuse boards. We're looking for right size cable size for breaker protecting it, because if you basically every cable's got a basically a maximum breaker size, or how do I describe this, almost like it's called cable current carrying capacity, and it derates depending where it runs, but basically the breaker is supposed to protect that cable it's supposed to trip before it sets on fire basically, so we're looking for that as well. I don't know, I can't think today. Right then, insulation resistance, so we'll bang it on 100 volts. We'll do the same as we did before. So because it's a ring, all we have to do is connect onto the line of one and the earth of the other, like so. So that's on, and then 100 volts test, good. 500 volts test, good. We'll swap line to neutral, get that on there, test. Oh, sorry, I normally go 100 volts data. Oh well. And then we'll go line to earth. So 100 volts again, just in case there's that fishy going on, and then up to 500. So how I do it. Right then, so that's the insulation resistance test done, and that's all the tests are done really. So as far as things that's kind of cropped up, we've got dodgy socket down here. Wanted to head and find the earthing on the lights, so we've basically earth this grid, and that's all earth now. Because we took it off, we might as well put a link in and earth it all up, so that's all earth now. We've got good readings there. So the things that have cropped up have been the down rating of the breakers. So there's like 2 cables going in one on a 32 and it's not a ring, so then you down rating to a 20. That's happened a few times on these circuits. So again, we'll look into the circuit, see if we can find where the break is. But worst case, yeah, we'll have to down rate those and see if we get good earth readings at all the points. So a bit annoying, but you got to do what you got to do. What you got to do. So that's me done down for testing. Now we've got a little surprise. So we've got a mate from Manchester. I think it's from Manchester. So Cablesmith Electrical, he's over my neck of the woods. So yeah, we're gonna try and push him out, you know. Now he's at a place called Liversidge doing a rewire, so we're gonna visit him at the end of this video, see what he's up to. There we go, here's the big surprise then. Let's see who's behind door number 1. Hey, so Cablesmith
Electrician in Yorkshire this week only.
Oh, I like it, I like it. So, I don't even know your name, I know you as Cablesmith Electric Sean from Cablesmith. I just know him as Cablesmith, that's funny that. It was like that with Wayne, when I met Wayne, well, when we did the podcast. Yeah. I just know him as A1. I goes, what's your name, Wayne? It feels weird calling you Wayne.
Yeah, it's like that with loads of other electricians online and stuff, innit?
I know.
So do you not do the podcast with him anymore?
No, we're doing it. So we're pumping out videos. I'm just going to send it over to edit, and she edits it and then sends it over. So some more podcasts to come. But yeah, we're going to have a look around this job then, and he's going to show you his process of how he does a rewire. Here we go then. So maybe Sean. Sean, it's Sean, isn't it? Not Sean, yeah. Cablesmith.
Cablesmith Cribs. I'm going to show you around.
Welcome
to me
humble abode.
So where we're at.
What's with this dodgy fuse board location then?
Pardon?
Dodgy fuse board, it under the sink, wasn't it?
It was under the sink, yeah, but we're going to be relocating that. We've moved that into this cupboard. Say you're through. We're only first fixing this, and that's it. We're leaving it to then be plastered and all that. So.
Are you back again then once all that's sorted, is it?
Yeah, come back September, I think. So a new fuse box. There is actually a fuse box as well. Is going in there.
Nice. Looking good.
It's all underfloor access, but we've not got anything other than the feed, the new feed going there. And in the loft we've run cable basket down both sides.
Yeah.
So everything's running on a basket.
But I'll have to check that out. That's a new one for me. That's look nice and neat on there.
It will do once it's all tied in.
That's a good idea, that, to be fair.
It's just because it's so big and so long.
Yeah, is it all boarded out on that?
It's boarded through the middle and then basket either side.
That's genius, that. Yeah. I like that. I might be stealing that one, bud.
It's quicker, to be honest. It cost you a little bit more, but you save a lot of time.
You have to lift the boards up again back down.
Yeah, so these were existing downlights, and obviously that was a fan. So the customer wants four downlights going in, so obviously we're using that fan hole. It's just going to push them up out of the way and patch it up, and then we're putting a new inline fan in this section here. It's already vented out the roof actually, which is a bit
nice. That's best bet, isn't it? You don't have to cord cutting, do we? We don't like that.
Nice little roof vent. You got up there, Ryan?
It's alright.
It's hot on my mum. Where were we? Let's see. Yeah, so it's got quite a lot going on in this. It's like I say, it's a bungalow, but there's a lot of sockets. It's pretty much every corner. He's got a projector socket there.
Nice.
A screen socket there that's going to drop down. Downlights in this room. And then we've got TV and data in every room as well. And the garage is going to have a data point and obviously a little fuse box supply, which we've got to get in underground.
Like it.
Look at that view. You get to see views like this all the time, don't you?
Yeah, it's alright, isn't it? It's a good thing about living on hills there, you know?
When I look out my back window, this is pretty much what I see. Just another wall.
That's funny.
But yeah, we've got quite good access underneath.
Oh yeah, that is it's big 3 metre length. Oh, I'm not going to make you. Look at this for depth. Keeps on going and going. That's alright, that, isn't it?
Yeah, and it's dry.
Look at that. That's luxury right there. There's a good 4 footer crawling, isn't it?
So this one could have been wired either way. The reason we've not wired anything underneath though is just because of like maybe rodents or water damage or anything. When it's because it's a bungalow, it's easy enough to just do it all above in it. So
I like it, mate.
That's what we've gone for.
Looking good. Looking good.
Capping. We use this old conduit stuff. Do you use that stuff or?
No, we
just nails.
clip direct.
I just think that's quicker, to be honest.
Yeah, that's alright then, isn't
Do
it?
you not think? Like, it takes me ages to put clips in cables.
We just don't clip it. We have about 3 penny washer
with the
fixes.
washers, yeah.
Just neat, done.
Yeah, washers,
Laughing.
That's true, yeah. That's true, so that's quick, yeah. It's when I see people using them as
Oh, I can't do with it.
quicker to just do that.
Yeah, it is, yeah, you're right, mate.
But most of it's been stud walls, it's just that egg box,
Yeah,
like
mate.
cardboard stuff, so
Look at this, it's always a bit of fun trying to mess about with this stuff.
Trying to get them up, and obviously these, because they're the old switches, he wants them all like that height now.
That's
so
alright then.
we've gone for that.
Looking good, mate. I like
At
it.
least the chasing side.
Oh, you got the basement
It's just the front screen.
front screen that goes after a minute.
It's,
Where's your Metabo then?
oh, that's back in.
He's got a big wall grinder, which I can't afford. He must spend too much money. He's
When I found out I was going to Yorkshire, I had my fingers crossed thinking, I hope it's not built out of stone, this house.
yeah.
Do you get a lot of them? Do you get a lot of stone walls? and stuff, or not?
Occasionally, a lot of it's like this. To be fair.
I went
Look at this big Hoover, big grinder. It's got loads of teeth on it, and that basically just takes it all. Big channel,
Yeah, that does
nice,
that.
neat and sweet.
I've not SDS'd any of that, that does the whole thing, so.
How we found them with pipes, cables that are existing?
Have
you gone through a few?
I've not done anything yet.
I'm scared to buy this base, just in case we like go through like a big pipe gushing.
I've not gone through a pipe with it yet, no.
It takes out a massive hole through the middle of it.
Yeah. Ready to solder a new section in.
Yeah.
No, I've not done anything, but.
Nah, it's looking good, mate. It's looking good. Right then, so you've seen Sean's process from Cablesmith Electrical. If you want to follow his channel, I'll put it in the description. So yeah, if you like this kind of content, hit the like button, hit subscribe, hit the little bell notification to know when we next upload. So have a good one from me and Sean. I'll see you on the next one. Can't speak today.